Uh, Good afternoon to all of you. Today I am going to teach the most important topic of the computer architecture, uh, that is known as the memory. In this memory section, another most example point is the cache memory and its mapping. Okay. Now, first I explain what is the cache mapping. Then second I explain cache performance. Then I explain about the three different type of the mapping of the cache, and some numeric example we explain the better understanding of the cache three different type of the mapping. So firstly I explain what is the cache. Cache memory is very special type of the memory with very high speed memory. This memory is also known as the very high speed memory. It is cache memory. It is also known as used for the to increase the speed of the processor or CPU. It means this is the speed up synchronized with the high speed of the CPU. It means the cache memory is mainly used for the speed up and synchronize of the CPU. Now this is the third point of the cache memory. Cache memory is very costly than the main memory and the secondary memory. This is another important point about the cache memory, that this memory is very costly but more economical than the CPU register. But it is more economical than the CPU register. Then cache memory is very important memory of the your computer organization and system. This is another point about the cache memory. Cache memory is extremely fast memory. I have already told that this memory is mainly used for the to speed up the CPU speed. Now cache memory is an extremely fast memory that act as the buffer between RAM and CPU. It means cache memory are established between the CPU and main memory. Now this is your cache memory that are designed between the main memory and CPU. Another point about the cache memory, it is, I have already told that the cache memory is extremely fast memory. How the cache memory are extremely fast? It hold the frequently requested data and instruction. Cache memory hold the data and the instruction so that they are immediately available to the CPU. It means in your cache memory data or instruction are hold, and when CPU asked any data or instruction, then that instruction is provided by the cache memory rather than the primary memory. This is the main concept of the cache memory. Now we move another important feature of the cache memory, that is known as the cache performance. There are the two parameters by which cache performance are calculated. First one is the cache hit, second one is the cache miss. What is the cache hit? If CPU asks for the data and instruction, if CPU asks for the data and instruction from the cache, if data or instruction is found into the cache memory, then this process is known as the cache hit. And if data is not found into the cache, then this process is known as the cache miss. If the processor find the memory location in the cache, then this is known as the cache hit has been occurred. If data and instruction are found into the cache, then this process is known as the cache hit. Very simple. If data and instruction are not found into the memory location, then this is known as the cache miss. Now, this is the mathematical formula by which we find the hit ratio. And what is the miss ratio? 1 minus hit ratio is known as the miss ratio. What is the hit ratio? Total number of the hit, and that is the hit plus miss is known as the hit ratio. These are the two parameters by which we find the performance of the cache. If the cache hit ratio of any cache memory is 99%, then that cache is performance of this cache is much better. If the hit ratio of the cache is 99%, then what is the miss ratio? 1 minus 99, it means 0.09% is known as the miss ratio. If the miss ratio is minimum, it means that cache is much better than, and the performance of the cache is best. Now, on the basis of the communication between the CPU, cache and memory, there are the three different type of the mapping are involved into the cache mapping. That is known as there are the three different type of the mapping used purpose for the cache memory, which is follows as the direct mapping. Second one is the associate mapping, and the third one is the set associate mapping. They are the three most important type of the mapping used in the cache mapping. Direct mapping, the concept of the direct mapping is based on the mainly pigeonhole principle, and in the concept of the associate mapping is based on the any pages can be allocate into any pages into the cache memory. And in set associate mapping, the total cache are divided into the n number of the set. Now, in direct mapping, I explain much better what is the direct mapping. The direct mapping, the simple technique known as the direct mapping, map each block of the main memory. We are take the very simple example to explain the direct mapping. Now, we can suppose this is the RAM. Now, this is your cache. In direct mapping, we can suppose here 16 number of blocks 0 to 15 and here 0 to 3. In cache memory, total 4 number of block, and in your main memory total 16 number of blocks. What is the direct mapping? Block B0 accumulate from the first block of the cache, B1 are accumulate in the second block of the cache, B2 are accumulate in the third block of the cache, and here B3. Now, this is the total 16 number of block B0, B1, B2, B3, B4, B5, B6 dot 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 B15. Total 16 number of blocks are accumulated in such a fashion that in first block of this block are accumulated here, B1 block are accumulated here, B2 block are accumulated here, and B3 block are accumulated here. What is the procedure for the next mapping? And B4 block accumulate here, B5 block accumulate here, similarly B6 block accumulate here, and B7 block are mapped here in this block, and so on. B8, B9, B10 and B11, B12, B13, B14 and B15. It means in the first block of the cache are the fixed for the number of block into the main memory. It means the first block of the cache are involve only B0 block, B4 block, B8 block and B12 block. Similarly, in the second block of the cache can be mapped with B1 block, B5 block, B9 block and B13 blocks. Can you see the this definition are explained by this example? Non-direct mapping, each block of the main memory are only possible into the cache line or direct mapping. Assigned into the memory are a specific line into the cache. It means the B6 of the block of the main memory are a specific location into the cache memory. It means B6 are always in this memory allocation. Similarly, B15 block of the main memory are a specific location into the cache memory, that is known as the block number 0. It means the every block of the main memory are fixed into the cache memory. Such kind of the mapping is known as the direct mapping. Every block of the RAM are fixed into the cache. This concept is known as the direct mapping. One very famous numerical equation by which we can accumulate all the number of block of the main memory into the cache memory, that is known as K mod n. K mod n. What is the K? What is the K and what is the n? K is the number of the block into the main memory. And what is the n? The number of block into the cache. It means B10 of the block of the main memory are accumulate 10 mod 4. What is this answer? That is 2. It means block number B10 are accumulate into the cache, that is block number or line number? Block number 2. By this mathematical formula, we calculate the every block of the RAM are mapped into the cache memory. That is the main concept of the cache memory. Now, this is the address generated by the CPU regarding with respect to the main memory and with respect to the cache memory. This is the address for the main memory and now this is the address of the cache memory. The address of the main memory is also known as the physical address, and the address of the cache memory is also known as the logical address. Physical address are divided into the two parts, that is known as the word offset and block offset. Tag is also known as block offset, and this is the word offset. When this data are mapped into the cache memory, then there is no change into the word offset. This point is very important. When we are mapped any data of the RAM into the cache, then the word offset are not changed. Only change the tag. Tag are divided into the, that is known as the tag, or this one is known as the index. What is the tag and what is the index? Or we can say that the block offset of the physical memory tag is also known as the block offset, or this is the block offset is also known as the main memory, and block offset is also the combination of the block offset and word offset is known as the physical address. Block offset are divided into the two parts, that is known as the tag and index. What is the tag? Tag represent in each block or line of the cache how many number of blocks are accumulate of the RAM into the cache. Taking this example, in each block of the cache there are 1, 2, 3, 4. 4 number of block are accumulate from the RAM. It means the tag size is 2-bit. And what is the index? Index is the total number of the block is in the cache memory, that is known as the index. Or we can say this concept is known as the index, or this concept is known as the tag. So tag represents the number of blocks. I write here. Index is known as the number of blocks in cache, or number of, in some book the block of the cache are written as line of the cache. And what is the tag? The number of the blocks can accumulate from main memory into the cache memory. That is the logical address are converted into the physical address. Now another very most important mapping, that is known as the associative mapping. Before I am going to explain what is the associative mapping, we take the very simple numeric example. We can suppose that in RAM total how many blocks? Very simple example, 16. It means this block B0, B1, B2 dot dot dot, this is B15 number of block. We assume that RAM consists of the 16 number of blocks, and in cache, assume 4 number of lines or blocks. That is cache, this is the RAM, that is the line number 0, or we can say that block number 0, B0, B1, B2, B3. All 16 blocks are accumulated into the 4 number of blocks. It means in each block can accumulate 4 blocks. According to the direct mapping, B0 is here, B1 is here, B2 is here, B3 is here. But according to the associate mapping, there is no fixed of the any number of blocks in the any number of the cache. It means B0 can accumulate here, B0 can accumulate here, B0 can accumulate here, B0 can accumulate here. But in each block can accumulate only the 4 number of blocks, and any block can be accumulated anywhere into the cache. That is the freedom is provided by the associate mapping. But in direct mapping there is no freedom is provided. Okay. Now B0 can accumulate here, B0 can accumulate here, B0 can accumulate here, and B0 can accumulate here. It means all 16 number of blocks can accumulate anywhere in these blocks. But at the same time, one block can accumulate any one block, not for here, but can accumulate anywhere. Similarly, B can accumulate here, B can accumulate here, B can accumulate here, B can accumulate here. And all block can accumulate anywhere. This is the main concept, and in each block 4 number of block can be accumulated, and any 4 number of blocks B0, B3, B5, B10 or B15 can accumulate here, not more than 4. The memory used to store the content of the address and the memory word, any block can go the any nil number of the cache. This is the main algorithm of our cache associate mapping. Any block can go into the any line number of the line or block, both are the same definition regarding this references. This is the again, this is the physical address of the RAM, this is the logical address of the cache memory. I have already told that the word offset are not changed in any mapping. Only tag is also known as, I already told that, that is the block offset of the main memory, that is also known as the tag. And when physical address are converted into the logical address, then block address are converted into the two part. First one is known as the tag and index. Index is also known as the set offset, and tag are the same and the meaning of the same. How many number of the block can be accumulated into the cache is known as the tag, and the number of the block are available into the cache is known as the index. Now this is the brief introduction about the two mapping, that is first one is the direct mapping and the second one is the associate mapping, and the third one is the set associate mapping. It means these whole blocks 1, 2, 3, 4, this block are divided into the two group, that is set 0 and set 1. Now this is the our RAM. In set associate mapping, we can say that is the combination of the direct mapping and associate mapping, that is known as the set associate mapping. The cache memory are divided into the n number of set. Here we divide the cache memory in the two set, that is the set 0 and set 1, and all the block of the RAM are classified into the two set, that is the set 0 and set 1. This is the example of the number of block into the RAM, and here is the simple example B0, B1, B2 and B3. B0, 16 number of block can be accumulate 4 number of blocks. It means 4 blocks can be accumulate in this block, 4 block can be accumulate in B1 block, 4 block can be accumulate in B2 block, and 4 block can accumulate in B3 block. That block B0 can accumulate here, B0 can accumulate in set 0 or either block 0 or block 1. Similarly, B1 are accumulate here and here. B2 can go for the set number 0, but B2 block can accumulate any number of block 0 or 1. B3 can accumulate either this block or this block. This is the set, this is the concept of the set associate mapping. Similarly, B4 here and B5 here, but anywhere or either this block or this block. It means we can simply say that it is set associate mapping is the combination of the direct mapping. And now we conclude all this cache mapping, and next lecture I am going to solve this some numerical example. First here we explain what is the cache mapping. Cache mapping is very fastly mapping, economically very fast. Cache mapping used to fast the speed of the processor, and cache mapping is also provide the data and instruction to the CPU when it is required. But cache mapping is much economically than the register. Cache mapping is costly than the RAM, but cache mapping is much economical than the register. That is the some main important feature about the cache mapping. Again, next in I am explain about the what is the configuration of the cache. Cache are simply designed between the CPU and main memory. Then I explain here what is the performance of the cache. Cache, there is a 2 parameter by which we can find the cache performance, cache hit ratio and cache miss ratio. If this page is found or if the data are found into the cache, then that is known as the cache hit. If CPU need the some data and data is not found into the cache, then that is known as the cache miss ratio. For the better performance, cache hit it must be high. If the cache hit ratio of any cache is high, then the performance of this cache is very high. Then I explain about there are the 3 different type of the mapping by which data are mapped from main memory to the cache memory. There are the 3 different type of the mapping, that is direct mapping, associate mapping and set associate mapping. In direct mapping, simply data are transferred from the main memory into the cache memory with the help of the pigeonhole principles and K mod n, where the K is the number of block into the cache and n is the number of block into the RAM. Direct mapping, we can also say that the every block of the RAM are fixed into the cache memory. This concept is known as the direct mapping. This is the very simplest technique by which data or the number of block of the main memory are mapped into the cache memory. We taking the very simple examples. For example, the block B1 of the RAM are accumulate with the cache in block B1. Similarly, block number 15 are accumulate in block number 3. With the help of this formula, we can find the position of the every block of the RAM into the cache. In the second, in the next, I explain what is the logical address and what is the physical address. Logical address, physical address are classified into the two parts, word offset and block offset. What is the word offset? Word offset actually how many words are present into the each block into the RAM. And what is the block offset? The number of the block available into the RAM. This is the physical address. When the physical address are mapped into the cache memory, then physical address are calculated into the converted into the logical address. In this case, there is no change of the word offset, but the block offset are converted into the two part, tag and index. What is the tag? Tag is simply known as the number of blocks can be accumulated into the cache. And what is the index? Index is the number of blocks available into the cache. This is known as the logical address of the cache memory. Next, I explain what is the associate mapping. Associate mapping is very simple. In associate mapping, there is no limitation, no boundary position. Any number of block of the RAM can be accumulate any number of the block into the cache. This is the main concept of the associate mapping. Any block can be into the any block of the cache memory. This concept is known as the associate mapping. We are taking the very simple numeric example and explain what is the associate mapping. Now we explain what is the set associate mapping. In set associate mapping is the combination of the direct mapping and associate mapping. It means the whole memory are cache whole memory are classified into the two part, that is known as n number of the parts, or we can say that n number of the set. Here this memory we can divide it into two sets, set 0 and set 1. It means the block B0 can accumulate in set 0, but anywhere number of the block. B1 can accumulate in set 1, but any number of the block. This is the concept of the set associate mapping. And same word offset is not changed, but the block offset again we are classified into the two part, tag and index. What is the tag? Tag is the how many number of the blocks can accumulate into the cache. And what is the index? Index is the total number of the blocks. Now for the better understanding, we meet for the next classes for the numeric example for the cache mapping. Thank you.